Today we're going to look at congruent figures. A figure is a shape, diagram or illustration. So it could be a rectangle, it could be a triangle, it could be a diagram of how something works, or it could be an illustration, a picture. Congruent figures have the same size and shape. So congruent figures are exactly the same shape, but they may be changed in some way, but still look exactly the same. These four shapes that I've got on the right hand side here, these four shapes are all congruent. Even though I've sort of moved them around a bit, they're all the same size, they're all the same shape. So a copy of a figure that is reflected, translated or rotated is still congruent to the original figure. It's still the same shape, but we've reflected it, so that's either we've flipped it about one axis, we've reflected it as if in the mirror. Translated means to have moved it, or rotated means we've turned it around. So for example, if this is my original shape here, this shape below it has been reflected, it's been flipped. As if we've put it next to a mirror, and this is the mirror image on this side. This shape here, compared to the original, has been rotated. It's been rotated 90 degrees. This is a rotated figure of this original one. And this shape down the bottom here is a translated one. It's been moved, so it's been shifted downward. So all of these figures are still congruent. They are all congruent. They are all essentially the same shape, they've just been reflected, translated or rotated. So corresponding, that's matching parts of two congruent figures have the same geometric properties. So geometric properties are properties that a shape might have. So that could be the same angle at a certain point, it could be the same side length, either of those two things. So these shapes, they're all congruent. So these two parts here are corresponding. These two corners here are corresponding. All of these ones here have the same geometric properties. This vertex here has the same angle at each point. Each of this side here, this side here, this side here, and this side here are all corresponding. They all have the same properties, they all have the same length, they all have the same side length. Okay, so if we've got two congruent shapes here, two congruent triangles in this case, we can see that they've got right angles, two right angles. We've got two angles marked with a circle with a dot, and two corners marked with a hollow circle, a circle that's not filled in. So these angles are the same, that's what they're saying, that these angles are the same here. So we can see that C corresponds to E, they've both got the same angle there. A and F both have a right angle at them, so they're corresponding. And B and D are corresponding as well because they have the same angle at their point as well. So we've given the triangles names here. We've given each vertex, each point, a name or a letter to give it a name. So we can see that vertex C corresponds to vertex E. So a vertex is a part on a shape where two lines meet, where two lines intersect. So C and E have the same geometric properties. They are corresponding. Side AB corresponds to side FD. So side AB, we're going from the right angle to the hollow circle, and we're doing the same on the second triangle, going from the right angle to the hollow circle. So AB, FD. Note that it's not AB to DF, because we'd be going in the opposite direction. We'd be describing it in a different way. So we'd be describing it in a non-corresponding way. We need to make sure that we've got the order right. So A and F are the same corresponding vertices, and B and D are. So A, F, B, D. So AB to FD. So angle, and this isn't a symbol here for an angle B, okay, so angle B is the hollow circle there, corresponds to angle D. So angle D corresponds to the hollow circle on the second triangle. Now this is a mathematical statement here that says triangle ABC is congruent to triangle FDE. So this is the name of the first triangle, this triangle here, triangle ABC, and we've ordered it. We've just given it we've chosen the order that we're going to talk about the vertices in to name our triangle A, B, C. We need to make sure that whenever we're naming something, we just do it in an order around the shape, especially if we've got a quadrilateral and we've got more than 3 sides to name. Is congruent to, this is 3 lines, like an equal sign with another line on top of it, and that means it's congruent to. And triangle FDE. So notice that we've talked about the corresponding vertices when we're naming the triangles. So A and F are corresponding vertices, B and D are corresponding vertices, and C and E are corresponding vertices. So we've named them in the same order. So here we've named it A, B, C, and here F, D, E. We've named them in the same order, gone from right angle, hollow circle, filled in circle, right angle, hollowed circle, filled in circle. So let's have a look at an example. We've got 2 quadrilaterals that are congruent. They are congruent. Name the objects in quadrilateral EFG that correspond to these objects in quadrilateral ABCD. Sorry, EFGH is the first quadrilateral. So here we've got a quadrilateral EFGH. Notice we've named them as we've gone around the edge of the quadrilateral. We haven't gone EGFH and crossed the quadrilateral. We've named them going around. And the same with ABCD. We've got the quadrilateral ABCD. So we need to look at which object in this quadrilateral corresponds to vertex C. So if we find vertex C here on this quadrilateral, this is vertex C here, we can have a look and try and compare the 2 shapes. And see what's happened. They are congruent, so it must have been either reflected, translated, or rotated. So let's have a look. If I kind of imagine it, I can see that if I rotated this one around about 180 degrees, about 1 foot, a half turn around, then I can see that they would match up. We've sort of got the longest side here being on the top, okay, if I was to rotate it around. The shortest side here would be on the opposite side, and this second longest side here, it would be up here. So I think that vertex C would match up with vertex G. So vertex G. Both of them, we can compare the actual properties. If the properties are of those vertices are the same, then there's a good chance that they could be corresponding. So we could have a look and see that this is the smallest angle here, and G is opposite the smallest angle. So this is the smallest angle in this one, and C is opposite the smallest angle in this quadrilateral here. So vertex G seems to be opposite the smallest angle. Okay, so that's why we can say it's vertex G. Let's have a look for, side AB. So side AB, I said, is the longest side. It's the longest side in our quadrilateral. And the longest side in our quadrilateral here is EH. And we're going from, when we're naming AB, we're going from the smallest angle to the biggest angle. So EH, we're going from the smallest angle to the biggest angle here as well, EH. So side EH is the longest side there, and they are corresponding. Lastly, we're looking for angle C. So angle C is this angle here, the angle inside here. So angle C is going to be matched to angle G because they're at the same vertex. So the answer for C is going to be angle G.